when we see a typical mechanical engineering curriculum out there is a course in manufacturing technology. Usually ManTech 1, ManTech 2, different curricula emphasize it differently. But a typical manufacturing technology course's approach to manufacturing is very superficial, it sometimes appears. They don't really explore this materials processing angle and how the material structure really is the underlying determiner of productivity. What can we do to really change the narrative on that? How do we get to a more well structured manufacturing technology course?
Very, very good observation. I also took ManTech 1 and 2 here. I found at that time ManTech was composed of a chunk related to machine tools, loosely speaking. Of that,
Like you're introduced to the names of multiple machine tools.
and every part in the machine tool. We had a picture of a lathe with every part labeled, right?
Which is good, but
Yeah.
we have to go beyond that.
Yeah, certainly. But the second part of the ManTech course at that time was metrology. And I found that the metrology part, the scientific aspects were emphasized, uh, or statistical aspects, scientific aspects, like optics, depending on what technique you are using. Yep. I think the reason there is always the design of these courses are challenging is, what do you teach the student? If you're a BTech student, do they go out with some superficial knowledge about lots of things in manufacturing, or do they go out with knowledge about core scientific aspects, core engineering science aspects? And it's a difficult decision to resolve this, in as much as when you have an undergraduate program, you say, do I tailor my undergraduate program so that the students coming out are trained to go to grad school, or do I train them to go into industry? Right. So the same dilemma exists here too. Right.
Yes.
And for the question of going into industry, or you train them as graduate students, the answer is clear. You have to train assuming some significant fraction go into industry, right? Because the graduate program and cannot accommodate. There are no jobs at academia or research labs for that large a volume, right? So in the same way here, there is this dilemma. I think one approach to addressing this issue is, perhaps stick at the undergraduate level with the same philosophy, but at the master's level, you don't do this replication of what you do. You start linking it with manufacturing processes, materials processing, with disciplines like material science, mechanics, sensing, signal processing, things like that, right? So, but it really requires a unique type of teacher to address, who can address all this. Different ways to ensure that the students have backgrounds in these other disciplines, right? And then integrate them in a course. So a master's level course or set of courses, right, which uh, emphasizes the materials, mechanics aspects, thermodynamics aspects,